this question. You are to say PQR is a point on the circle center K, and KR is a bisector of angle this, and this is equal to this, and this is this. So you have to find angle Q and angle P. That is angle RQP, angle RQP. This place, you have to find this place, and angle SPQ, and this place. So this is circle geometry. Some of you don't like circle geometry, and it's very, very simple. So once you know the theorem, and then the rest is very simple. So look at this. They tell you that this one is the center of the circle. So you note something like that. And then another thing you see here is bisector of angles. So you note those two. One, if this is the center of the circle, and a line come from this side and another come from this side, so you should know that these two sides are radius. So angle RK, that's line RK, equal to line KX, which is base radii. So this is radii. That two place to be what? To be radii. Therefore, the base angle here and the angle here, they are equal. That's base radii, or base of isosceles triangle. So if two sides are equal, you can say base of isosceles triangles are equal. So you can have it like this, that angle XRK plus angle RKX plus angle RSK equal to 180 degree. That's sum of angles in a triangle. This is why you write it in full. You want to write it in exam. So I just shorten it. So that's sum of angles in a triangle. Then here you are. Then you say that angle RSKT equal to what? Angle RSK. So you say it's base radii. So that's base radii, or base of isosceles triangle, as the case may be. So you can simply say that 2SRK plus RKX. RKX is 80 degree. So which is equal to 180 degree. So you have X2SRK equal to 180 degree minus 80. So 2SRK equal to 100 degree. So if you divide both sides by 2, RSK equal to 50 degree. Now look here. So you see me, since this one is what? This equal to this, so they are the same. So you can say this plus this, that's where we get these two up. So you not be confused about that. So you can now write now that since both of them are the same, SRK equal to RXK, which is 50 degree each. So here is going to be 50 degree, and here is going to be 50 degree. So now the first question states that calculate angle what? RQP. So this is RQP. So having that, you will see this is a cyclic chord. So a cyclic chord is a circle that inscribes a quadrilateral triangle. So, and look at this. These two opposite angles are supplements. So you know what I mean? That angle RSP plus angle RQP equal to 180 degree. So you say the sum of two opposite angles of a cyclic chord as supplement. So they are supplement. This proof is necessary. So don't just write down your answer without putting it there. So the theorem are necessary. So now, what is angle RSP? So angle RSP, this angle, these two angles. So that's 50 plus this. So you will have it as 91 degree plus RQP equal to 180 degree. Then angle RQP equal to 180 degree minus 90 degree. Angle RQP equal to 89 degree. So this one is 91. So that's how you have your answer. So you have solved the first question. So that's it. Now let's look at the other parts. Let's look at the other parts. So in other parts, you have to calculate angle SPQ, XPQ, this place. So it's still the same thing. But look at what they tell you here. They say that QR, this is KR, this is KR, line KR. They say that line KR is a bisector of angle XRQ. So that is XRQ. You know the meaning of bisector? When you bisect an angle, So the bisector will divide the angle into two equal parts. So that's it. So that's what I want you to know there. The language, not the something. So once you know that, you got your answer. Any angle you bisect is going to divide the angle into two equal parts. So that's it. So that's what they are telling you here. It means if this angle you bisect into two equal parts, one of it is 50, automatically the other one is what? Is 50. Because you see that the bisector of angle SRQ divide it into two equal parts. Therefore, angle XRK is equal to angle QRK. So that's it. Since it's divided into two equal parts, so you see that angle SRK equal to angle QRK. So that's it. So 50-50. So you want to calculate this place. Same reason. So you will have angle SRQ plus angle SPQ equal to 180 degree. So you put it there again. The sum of two opposite angle of a cyclic chord are supplements. They are supplementary. So that's it. So here is going to be what? 50 plus 50, which is 100 plus SPQ equal to 180 degree. So SPQ equal to 180 degree minus 100 degree. SPQ equal to what? 80 degree. So that is it. So you have your answer. Thanks for watching. Okay, look at something, because in circle geometry you can have something more than this. So I quickly want to remind you some of the things that you can make there. So if you have a circle like this, so here you have this, you have something like this. This angle here is angle at the center, this angle of the circumference. So you should know that if they give you this one, is always times 2 of this. If this one is x, this one is going to be 2x. So that what you call angle at the center is 2 times the angle on the circumference. So if they give you this one as 20, this one is going to be 10. That is going to be half of it. So you mind that. Another thing is angle at the same segment. So if you have something here, this angle at the same segment, so you can have as many as possible. So if they ask to prove, is this one you are going to use to prove it? The angle at the center is 2 times the angle on the circumference. All the angle that you see here, they are all angle on the circumference. So here, they are on the same segment. So here, so the angle here, 2 times of this and the like. So all this angle here, they are all equal. X, S1, S2, S3. So you can see S1 equal to S2 equal to S3. Even if there are 20 there, they are going to be equal to each other. So that is what you call angle on the same segment. So that's it. So they can give you any question there. So to solve, as regard that, so don't forget also that angle at the semicircle is what? Is 90 degrees. So angle at the semicircle is what? Is 90 degrees. So you mind that also. Then which other one? Angle at the same segment and go. Then you have what we call the alternate segment. So for alternate segment, so here you have an angle like this. So here, so this target. So you have this angle here. So is alternate segment to this. So as this one is equally alternate segment to this one. If this one is y, this one is y, y1, y2. So they are alternate segments. So you mind that. Or so you have alternate segments. So that's what is there. And the other one, let's just have that.